Hi everyone, just a short demo video to present my first prototype of a digital twin of an experimental setup for e-learning. This is a hydronic heating system with a single loop, one boiler, one variable speed pump, several valves that I can choose, and one radiator that is connected to a room. You can interact with this digital twin. We can change the speed of the pump, we can change position of the valve, and when we open the valve, then the flow starts, and there is some heating in the radiator that changes the temperature in the room. We can change the speed of the pump, we can change also the type of valve. We can have a control valve that is easier to adjust. You can see on the side different graphs that show different state of the system. So in here there's the pump and the system curve and the operating point that changes if I change the speed of the pump or the position of the valve. It will change the flow in the loop. It will also affect the heating power of the radiator and the return temperature. You can see here the curve of the pump power, pump efficiency, that changes as function as well of the speed and the flow. And the same for the heating power, fluid return temperature, and heating efficiency that changes as function of the flow. And at the top here there's a logging of the different state of the system. So indoor temperature, outdoor temperature, the fluid return temperature, the flow in the loop, pressure in the loop, the power, heating power and the pump power, and the efficiency of the pump. You can see that all the states of the system are updated on the different indicators: power of the pump, pressure difference, the flow in the network, and then the different valve. If I turn off the pump, well, everything shuts down. There is no more flow. Put back the pump. Boundary condition is the outdoor temperature. I can change it to dynamic temperature. So there is a little change of the outdoor temperature. So now I can see that my temperature is a bit unstable. I can choose another type of valve, thermostatic valve, where I can define a set point. And this valve will regulate the flow in the radiator to maintain the right temperature that I want. So I can change the set point, for example 22 degrees, and then there will be a bit of adjustment and then it will reach stable temperature.